everyone, my name is Ravi Prakash and welcome to the continued class of mensuration. Okay, so here we'll continue the concept of shortest distance which we started in last class. Okay, we'll continue here also shortest distance. Okay, so see, our next problem is there's a cube like this. Okay, there's a cube. Okay, let me make it like this. There's a cube. Okay, so in this cube, an ant is coming like this from point A and point B. Okay, so ant has to travel from A to B. What could be the shortest distance? What could be the shortest distance covered by the ant? What could be the shortest distance covered by the ant? Okay, see here again, it's a very nice concept. Starting from A, ending at B. Starting from A, ending at B in a cuboid, in a cube. Let's say there's a cube of side A. Okay, so like in a room, you can imagine in a cube shaped room, from the top corner of the room, of the room to the opposite bottom corner, an ant has to travel. Okay, so ant has to travel from the top corner to the opposite bottom corner. Okay, what could be the shortest distance? Now don't say diagonal, because it's an ant, right? It's not a sparrow, right? It can't fly. Okay, so ant will be crawling on the surfaces. Okay, so top corner to opposite bottom corner. What is the shortest distance traveled by the ant, right? Now see here, I'll take a few cases here. Okay, see, because I know what you people are thinking. So many will think like this. Okay, it's a cube, so ant could go like this. Okay, or for clarity, let me make a 3D diagram of cube like this. Okay, diagram like this. Okay, so I know ant has to travel from this point on cube A to this point here. Okay, opposite diagonal. Okay, so now see, many will think like this, that ant could come from A to this corner while crawling on the roof, and then come down from here, Okay, this could be one of the path. Okay, let's say ACB could be one of the path. Okay, ACB could one of the path, but actually, if you observe it, right, so in any 2D diagram, diagonal is the longest phase, right? In any 2D diagram, diagonal is the longest distance. Be it square of side A, in that what is diagonal? Root 2A. That is 1.4A, right? That is more than the side. Okay. In rectangle, L and B, root under L square plus B square. So that in any diagram, right? In any 2D diagram, diagonal is the longest distance, right? So A to C will not be true here, because diagonal, ant has to cover the diagonal. That means it is longer than required, right? You have to calculate the shortest distance. You have to minimize it, right? So actually it is ant coming somewhere in between here, right? Somewhere in between, that is point D, and again crawling from here to here B, right? A to D, D to B. So A to D, D to B, A D B is one path, right? So that means what is this? It is on the roof, right? This is a roof. This is a roof A. This is a roof, right? So on this roof, how ant is traveling on this roof? So ant is traveling from this point A to point D, right? So on the roof only, it is coming from diagonal to the opposite midpoint here D, and from that D, it is now just on that wall. It is crawling from this. Now this is wall. This is the front wall, right? On this front wall, ant is traveling from this point to this point. Okay, this is for roof, and this is for the front wall. Okay, this ADB should be the shortest distance, right? You can calculate ACB and check. Okay, you'll get ADB as the shortest distance. Okay, so I'll calculate ADB distance here. So what is ADB distance traveled? So ADB is right. If it is a side of cube of side A, so D is a midpoint. So this is A by 2. This is A by 2, and this is also A by 2, and this is also A. So this is 90 degree. This is 90 degree. So I applied 2 times Pythagoras theorem, right? For this triangle, what is distance AD? So distance AD is root under A square plus A by 2 square plus distance DB. What is DB? So DB is again A square plus A by 2 square. So A square plus A by 2 square. This is the total distance, right? Not this. This is the total distance. This plus this. So AD plus DB, right? So if you solve it, you will get A square plus 4A square, that is 5A square by 2. So 5A square by root 2, 5A square by 2 will cancel it, and the answer will become what? The answer will become root 5A. Answer will become root 5A. Okay. So it is root 5A is the shortest distance traveled by the ant. Okay. So I hope it is clear, right? Shortest distance traveled by the ant, right? Root 5A. A square plus A square by 4 is what? 4A square. 5A square by root 5A square. Okay. So you take A common, so root 5A by 2 plus root 5A, root 5 by 2. Root 5 by 2 plus root 5 by 2. Okay. So it will become how much? It will become root 5. Okay. So shortest distance traveled is what? Root 5A. So if ant has to travel from A to B, right? The shortest distance traveled by ant is how much? Root 5A, right? But this is the concept, okay? But you don't need to solve this much long, right? Again, we can apply the funda of shortest distance or a Pythagoras theorem in this question. Directly I can apply to get the answer root 5A. I'll show you how. See. Make a cube first. Okay. On cubes, I have made separate video of painting, cutting, okay, all those questions of maximum and minimum cubes, right? Everything I covered in separate video, right? In this, we're just covering the question based on mensuration, right? Or shortest distance in the cube. So see, in this cube, ant is traveling, I know ant is traveling from A to B, this point A to this point B, right? Just we need to see it, and the side of the cube is A. So you just need to see it when ant is traveling from A to B. Okay, the shortest distance traveled by, right? Again, I know the path, right? I know the path. So let's say ant path is this. Ant comes from somewhere here to here and drops down from here to here. This is the path of the ant ADB. Right. Again, if I tie an string on that path, if I tie a string on that path, so if I tie a string on that path and if I open it, the string is ADB. So if I straighten it up, the string becomes like this: A, B, somewhere in between D. Right. The string ADB. If I straighten it up, ADB. So I need to calculate length of ADB, right? So that means the shortest distance from A to B, right? So again, same thing. I'll calculate horizontal distance from here and I'll calculate vertical distance from here. Correct. What is the horizontal distance from here? A to this point. What is the horizontal distance? See, horizontal distance is from coming from A to B. Ant has traveled how much? See, so in horizontal distance, ant has traveled this A, and ant has also traveled this A, right? This A. So ant has traveled this A plus ant has traveled this A. So in horizontal distance, ant has covered 2A, right? I told you how to calculate horizontal distance. Just on the path, trace horizontal line, right? Just from A to B, trace an horizontal line, right? So how ant will travel? So ant will, what is the horizontal line from A to B? From here to here plus here to here. This is the horizontal path of ant from A to B, right? If you didn't get this point, let's see. I'll draw again. I'll show you. Quite simple to understand this. Okay, it may be difficult in first go. Let's see. We'll do it. See, this is a cube. Okay. Now, See, ant has to travel from A to B, and I'm saying this has a right. Suppose this side I open it up. Suppose this side I open it up. Okay, this A becomes from here. This A becomes here. I open it up this side. This is A now. Okay, so it is same as ant is traveling from A to B. So this is a shorter distance, right? This is a diagonal, or this is the shortest distance. So ant will travel how much? So from covering from A to B, what is the horizontal distance traveled by ant? This whole line, that is how much? This I opened it, right? This is A, and again this is A, right? Total how much? Total 2A. This is what I'm saying. So horizontal distance don't get confused. Okay, this is A, this is A. So only this is also horizontal, and this is also horizontal, right? So both are horizontal only, right? Nothing is vertical here. So just trace a horizontal path from A to B, absolutely in horizontal direction. Just trace that path. So ant path is from here to here in horizontal, and again here to here, right? So don't drop diagonal, because I don't drop diagonal from A to B, because I'm covering horizontal distance. So horizontal distance, right? I told you, just open up this part here, right? It becomes like this. This A becomes here. So you can see now, this A comes here. You can see now, if A was here, what was the horizontal distance traveled by ant? A plus A, 2A. What is the vertical distance? Again A. So I get this answer AB, right? 2A plus A. So 2A and A. Vertical distance is 2A. Vertical distance is A. Horizontal is what? A plus A, 2A, right? So 2A. What is the answer? So answer is root under 2A square plus A square. That's it. What is AB? So AB is root 5A. So directly we'll get it. We got root 5A there. Directly we'll get it root 5A here. Root 5A here. Right. So beautiful concept, right? A super concept it is. Very important, right? Just see how beautifully it is. I've shown it. It's opening up here, and this is whole the horizontal distance. You understand this concept here? This A plus A. Right. So horizontal distance traveled by ant, or the shortest distance traveled by ant from the top corner to the opposite bottom corner is how much? Root 5A, if A is the side of the cube. Now we'll take this concept to cuboid also. We'll take this concept to cuboid also. Okay. Now see what is cuboid here. In this, how to take this concept in cuboid. See, if I draw a cuboid again, everything will be same, just that A will become L, B and H, right? So in cuboid it is L, this is B, this is H. Again same thing. If I say ant has to travel from A to B, so ant has to travel from A to B now. Okay. So what is the shortest distance traveled by ant? Shortest distance traveled by ant from A to B. Shortest distance traveled by ant from A to B. That is top corner to opposite bottom corner. Okay, what is the shortest distance traveled by ant? So I know now, right? I know what is the path. So path of the ant is something like this, right? Path of the ant is something like this. Path of the ant is something like this. Starting from A, going somewhere in middle now, and again dropping from here to here. So path is ADB. Now I can't say it as midpoint because it is cuboid. No, it is cuboid. So it basically depends on L, B and H now. In cube, this was also A, this was also A. So I can directly say, okay, midpoint. But here I can't say midpoint, but I know the path is what? I know the path is somewhere in middle, and then A to B. So I can directly get this AB. I can directly get this AB. How I'll directly get this AB? I'll take the horizontal distance. I'll take the vertical distance. I'll get my answer. Right. What is AB here? So AB here is, what is the horizontal distance covered from A to B? I told you. This, just trace that path, right? So from here to here plus here to here, how much? Here to here is B, here to here is L. So horizontal distance covered is L plus B, right? This here to here is B, and here to here is L. So B plus L is the horizontal distance covered. What is the vertical distance covered by ant from A to B? This height, that is H. Height is H. What is the answer? So answer is root under L plus B whole square plus H square. Correct? L plus B square plus H square. This is the answer. So shortest distance AB, therefore shortest distance is how much? Root under L plus B whole square plus H square. Okay. So shortest distance for an ant to travel from top corner to the opposite bottom corner is how much? Root under L plus B square plus H square. Okay. Now we'll do one question here. We'll do one question to understand this concept. See, question is dimensions of a cuboid. Dimensions of a cuboid. Cuboid are 5 centimeter, 6 centimeter, and 8 centimeter. Okay, what is the shortest distance? What is the shortest distance traveled by ant? What is the shortest distance traveled by ant from top corner to the opposite, from top corner to the opposite bottom corner? Right, now again a super question, right? And if you have, because we have done all the concept, this question will become very easy, but it's a tough question, right? The dimension of a cuboid are 5. Because why it is tough? Because I have not mentioned the length, breadth and height. This I have not mentioned. Among 5, 6 and 8, which is length, which is breadth and which is height, it is not mentioned. That's why it is a tough question, but we'll do it very easily. See, now I know that by the previous slide, I know that we did this in previous slide. If length is L, if breadth is B, if height is H, the shortest distance from top corner to opposite bottom corner is, that is shortest distance of AB is not diagonal. Don't take it diagonal, because ant can't travel diagonally. Ant is not a pigeon, right? It can't fly. Okay, so it can't go diagonally. Okay, so shortest distance AB is how much for an ant? For an ant is how much? We have done this B square plus L square, right? Root under L plus B whole square plus H square. This we did in last video. Now we have to place any value of LBH. We have to place any value of LBH of out of 5 or 6 or 8, right? So it's quite easy. It's quite easy if you see it here. See, I have to minimize this distance. I have to minimize it, right? I have to minimize this whole data, right? So minimizing means, see, this L plus B whole square, when expanded, will become L square plus B square plus 2LB. So this L plus B whole square, when expanded, will take up one more term with it, right? L square plus B square plus twice LB. So if it on expanding, it takes up 3 terms. But I have to minimize this data. So I have to minimize L plus B. I have to keep L plus B as low as possible. Why I have to keep L plus B as low as possible? Because L plus B whole square contains the shorter dimension AB, contains L plus B whole square. L plus B whole square on expanding will become L square plus B square plus twice LB, right? That's why this contains 3 terms now. So on expanding, it take up one more term. So I have to keep it as low as possible. We have to minimize that value as much as possible. So that's why what we will do, we will directly give the values of 5 and 6. I have to minimize. So out of 5, 6 and 8, since I have to minimize L plus B, I'll give L plus B as 5 plus 6 whole square, right? And I'll give H as 8 automatically. H will get 8 because L plus B has to be as minimum as possible. Okay. So what is the answer? Answer is root under 11 square plus 8 square. That is root under 185. That's the answer. That's the answer for this question, right? Very nice question. There's the answer. Shortest distance AB is root 185. If you get this concept, You don't need to do hit and trial. That when you will get shortest with L and B as 5 or 6, with L and B as 5 or 8, with L and B as 6 or 8. Right? Don't have to do some any hit and trial, or you don't have to calculate 3 times. You don't have to do any hit and trial. Simply get the concept that since L plus B on expanding will become further large, I have to keep L plus B as low as possible. So out of 5, 6 and 8, the minimum 2 values I can give L and B as what? 5 and 6, right? Therefore, L is equal to 5, B is equal to 6, or vice versa, and H is equal to 8. This is the answer. So in a cuboid, whenever it's this kind of question, so always assign L and B as the minimum of the 2 values. You will get your correct answer every time. Okay. So I hope you got you got all this concept of shortest distance, right? Very nice concept of shortest distance here. In the next videos, we'll be doing now questions, right? We'll be practicing some questions now. Okay. And we'll see further how to do it for cone, frustrum, right? Lots of concepts in mensuration will continue in the next videos. Okay. Thank you.